This problem is about corrective lenses. So a person can see in this situation clearly up close but cannot focus on objects beyond 75 centimeters. She opts for contact lenses to correct her vision. Is she nearsighted or farsighted? Let's start with this question to answer, and then we will read further. So to answer this question, let's recall what is a nearsightedness. And in a nearsightedness, the eye can focus only on nearby objects. The far point is not infinity, but some shorter distance. In farsightedness, the eye cannot focus on nearby objects, although distant objects are usually seen clearly. So, by definition, our person is a nearsighted person. So the answer to the first question, A, the answer would be nearsighted. The next question is, what type of lens, converging or diverging, is needed to correct her vision? Well, why is the nearsighted? How is the nearsightedness happens? It usually is caused by an eyeball that is too long, although sometimes it is the curvature of the cornea that is too great. In either case, images of the distant objects are focused not at the retina. If this is if this is the eye and here is the retina right here, so the image is actually formed in front of the retina. So retina here. So what you want to have a corrective lens, okay, corrective lens that will bring this image back to the retina and form it here. So for that, we need a diverging lens. A diverging lens because it causes parallel rays to diverge and allows the rays to be focused at the retina and thus correct the defect. So I'm gonna say diverging lens for now, diverging, and we will see it also from our calculations. If you're wondering how we will see from our calculations, if we find the focal length of the lens and it becomes negative, that means we have a diverging lens. Okay, so let's continue reading our problem. Where it says, part C, what focal length contact lens is needed and what is its power in diopters. So part C, we want to find the focal length. Now to find that, we need to understand what is our distance of the object and what is our distance of the image. So let's remember that all the objects that are beyond 75, we want 75 centimeters, we want to bring it to 75 centimeters so the eye can see. So that means any object beyond 75, it's the same for that eye as the object at the infinity. So I'm going to say distance of the object is the infinity. So in other words, you want to bring the object, the image of that object to the point of where the person can clearly see, which is the image distance should be 75 centimeters or closer. So I'm gonna the furthest away is 75 centimeters, which is the furthest point. So let's recall. So this is on the left side of the lens, so distance of the image should be negative. Don't forget about that. Okay. Now to find the focal length, we need to use our lens equation. So 1 over DO plus 1 over DI equals 1 over f. So since DO is the infinity, this equals infinity. So this whole term approaches to 0. So we end up having 1 over di equals 1 over f. So focal length equals di, and it equals negative 75 centimeters. Well, note that we got the value of focal length to be negative, which in turn proves us that this is a diverging lens. Now the next thing, we have to find the power of this lens. So, and we know that power equals 1 over f, but we need to make sure that the focal length is given in terms of meters, because the power should be in diopters. So that would be 1 over negative 0.75 meters, which is the negative 75 centimeters. So this will give us negative 1.33 diopters. So let's box our answers. This is the power of the lens. This is the focal length of the lens. And we also have another part D of this problem, which is if the person chooses ordinary glasses over contact lenses, what power lens in diopters does she need to correct her vision if the lens is 2 centimeters in front of the eye? So if you put the lens, let's say 2 centimeters in front of the eye, so this is 2 centimeters, right? And let's say right here is the far point. Then your image should be formed right here. And an image from the lens will be di equals 75 centimeters minus 2 centimeters, which makes it 73 centimeters. And let's not forget to put our negative sign because it's the same side of the lens, while the distance of the object remains infinity. So if we do the similar analysis, we will get the focal length of ordinary glass lens equals again di, which equals negative 73 centimeters, and the power in diopters will be 1 over negative 0.73 centimeters, which gives us a value of negative 1.37 diopters. So as you can see, the power of lenses is different from the power of ordinary glasses. So be careful when you're saying what is the power of your lens, because you always need to ask whether you wanna you wanna have a ordinary glasses or you want to have a contact lenses. Well, thanks for watching and stay tuned for more.